Guna Math over here, and this is the 2014 AIME 2 problem 5. Here's a view of this problem. Real numbers r and s are roots of p of x is equal to x cubed plus ax plus b. And r plus 4 and s minus 3 are roots of q of x is equal to x cubed plus ax plus b plus 240. So you may immediately realize it's just p of x plus 240. And we want to find the sum of find the sum of the possible values of the absolute value of b. Okay. So let's just list our polynomials. P of x is equal to x cubed plus ax plus b, and I know these have roots r, s, and by the fundamental theorem of algebra I know it has 3 roots. So how can we find the third root? You may immediately see that this has no x squared coefficient, therefore by Vieta the sum of the roots is 0, so we can conclude that the third root will be negative r plus s. Now let's go on to q of x. Remember, same thing, p of x plus 240 roots are, remember, it's r plus 4, s minus 3. By Vieta, the sum is 0, therefore the third root is negative of r plus s plus 1. Great. So now our ultimate goal is to find the sum of the possible values of the absolute value of b. So now we know that b is going to be the negative of the product of the roots. So I'll just put as a side note b, we can easily do rs times r plus s. Okay, so that's just a side note over here. So how about now we just express p of x in terms of the roots, right? X minus r times x minus s times x plus r plus s. And then q of x can be expressed as x minus r plus 4, x minus s minus 3, and then x plus r plus s plus 1. Okay, and then now what we realize about these two polynomials is that the a terms are exactly the same. And how do we get a terms? It's just a pairwise Vieta relation, right? If we have 3 roots, x1, x2, x3, we know that a will be x1, x2 plus x1, x3 plus x2, x3. Just think about 3 choose 2. So let's just do that. We know a, by using Vieta on p of x, we know that it's gonna be, let's see, rs minus r times r plus s minus s times r plus s. This is equal to rs minus r squared minus rs minus rs minus s squared. This is equal to negative r squared minus rs minus s squared. Now let's go on to q of x. Maybe it's a little bit more involved, but it shouldn't be too hard as well. R plus 4 times s minus 3, and then we need to multiply these two, right? So let's just bring out the negative first, r plus 4, and then this is r plus s plus 1, and then same thing over here, we bring out the negative, s minus 3 times r plus s plus 1. That's good. We can now simplify this a little bit as r plus 4 times s minus 3, and we can factor out the r plus s plus 1, and then we'll get a remaining of negative r minus 4 minus s plus 3, so negative r minus s plus 1, minus 1. Okay, so r plus s plus 1 times negative r, negative s, negative 1. Okay, good. So now let's expand this. So we have rs minus 3r plus 4s minus 12 minus r squared minus rs minus r minus rs minus s squared minus s, and then minus r minus s minus 1 is equal to negative r squared minus rs minus s squared. Okay, so this looks like a plethora of information. Let's try to digest this. Let's see if we can group any rs terms. Rs is over here, rs is over here, rs is over here. Cancel, cancel, negative rs. Let's move on to the r terms. R over here, r over here, r over here. That's good. Negative 6r. Well, hold on. 4s. Oh, Wait, hold on. What am I doing? Negative phi r. Negative phi r. And then we have 4s over here. We have an s over here, negative s over here, negative s here over here. So 2s. And then we have negative r squared, negative s squared minus 13 is equal to negative r squared minus rs minus x s squared. How can we simplify this further? We realize conveniently that these three terms will cancel out. Great. So now we actually can simplify this tremendously. So we can actually maybe solve for s over here, bringing the phi r and 13 to other sides and dividing by 2, we get s is equal to phi r plus 13 over 2. That's great. So now our ultimate goal is to actually find this, and actually maybe we can even plug in s is equal to phi r plus 13 over 2 into this and try to simplify stuff, but I don't think that'll look good. Looks like we'll have to deal with cubics and stuff. So instead, I'm actually going to note a neat trick we actually noticed in the beginning of this problem. Q of x is just p of x plus 240. Therefore, if we plug in a root into p of x, we know that if we plug that root into q of x, we're going to get 240. And that's where this factored form comes particularly in useful. So if we plug in q of x, q of s is equal to s minus r minus 4. And then if we plug in s, we get 3 over here. So let's put the 3 over here. And then plugging in s into this gives us 2s plus r plus 1. We know that this is going to be equal to 240. And now what's so cool about this is we can plug in this. Hopefully something convenient will happen. We can find values of r and s. We can plug it into this to get all possible values, and we'll solve the problem. Great. So now let's look at this. This becomes, just bring it all the way over here, 3 times s minus r. S minus r will be equal to, get a common denominator, that's 3r plus 13 over 2. Subtracting 4 gives us 8 over 2. So 3r plus 5 over 2. Great. And then 2s is 5r plus 13. Plus r, 6r plus 13, plus 1, 6r plus 14. This is equal to 240. That's nice. We can factor out a 2. That'll cancel with this denominator. And then we can, so 3 times 3r plus 5 times 3r plus 7 is equal to 240. We can divide 3 on both sides and simplify to get 9r squared plus 21, 15, that looks like 36r, plus 35 is equal to 80. Bring everything to one side to get 9r squared plus 36r, 540, negative 45 is equal to 0. And then divide by 9 to get r squared plus 4r minus 5 is equal to 0. So a very nice quadratic, and this can factor as r plus 5 times r minus 1. So r is equal to negative 5 or r is equal to 1. If r is equal to negative 5, we'll just use this. That becomes negative 25 plus 13, negative 12 over 2. S is equal to negative 6. And if r is equal to 1, if r is simply equal to 1, this will be, s will be 18 by 2, 9. So now we need to calculate all possible values of b. If we plug in this first thing, we get 30 times negative 11, negative 330. Good. And then now if we plug in 1 and 9, we get 9 times 10, 90. 9 times 1, 118, 9. Good. And we get negative 90. To get negative 420. Put that positive because we want to find the absolute value, and we are done.